Hello everyone. This is second part of solution of miscellaneous exercise. So in this part we'll be solving questions 11 to 20 of the miscellaneous exercise of chapter integrals. So let us start. Question number 11. Integral of 1 by cos x plus a into cos x plus b. So we will be simplifying this. So 1 by cos x plus a into cos x plus b. So this can be written as 1 by sine a minus b, and sine a minus b is written as sine x plus a minus x plus b divided by cos x plus a cos x plus b. So the reason we are writing this as sin x plus a minus x plus b. So now once we use sin a minus b formula, so that will be coming as in terms of x plus a and x plus b. So let us see how it is coming. Sin a minus b into sin a minus b. So that is sin x plus a cos x plus b minus cos x plus a sin x plus b divided by cos x plus a cos x plus b. So now if you take term by term, 1 by sine a minus b is outside. First term will become cos x plus b will get cancelled, that is tan x plus a minus cos x plus a will get cancelled, tan x plus b. Now we have simplified it into this particular form. Now we'll be doing the integration. 1 by cos x plus a cos x plus b dx equal to 1 by sine a minus b, then integral of tan x plus a dx minus integral of tan x plus b dx. So that means it is 1 by sine a minus b, integral of tan x is minus log cos x plus a, then minus of minus log cos x plus b plus c. So that can be simplified using properties of log. 1 by sine a minus b, so log of cos x plus b divided by cos x plus a. So this will be the answer to this problem. Now we'll move to the next problem. X cube by square root of 1 minus x to the power 8. So integral of x cube by square root of 1 minus x power 8 dx. So this can be written as x cube, then square root of 1 minus x power 4 whole square dx. Now put x power 4 equal to t. So that implies 4x cube dx equal to dt. So that means x cube dx equal to dt by 4. Now if you take this as I, so now you'll replace I in everything in terms of t. So I equals to x cube dx is dt by 4 divided by root of 1 minus t square. So that is 1 by 4 dt by under root of 1 minus t square. So that will be 1 by 4 sine inverse of t plus c. So now again going back to x, sine inverse of t is x power 4. So 1 by 4 sine inverse of x by 4 plus c. So this is the answer to this particular problem. Now we'll move to the next problem. E power x divided by 1 plus e power x into 2 plus e power x. So let I equals to integral of e power x 1 plus e power x 2 plus e power x dx. Now put e power x as t. E power x equal to t. So that implies e power x dx equal to dt. So I will become e power x dx is dt divided by 1 plus t into 2 plus t. So this can be integrated using partial fraction. So let 1 by 1 plus t into 2 plus t equal to both are linear factors. So a by 1 plus t plus b by 2 plus t. So now simplifying, we'll be getting a into 2 plus t plus b into 1 plus t equal to 1. So when t equals to minus 1, a will become 1, and when t equals to minus 2, b will become minus 1. So the values of a and b are 1 and minus 1. So therefore I will be equal to integral of 1 by 1 plus t dt minus integral of 1 by 2 plus t dt. So that means now integrating log of 1 plus t minus log of 2 plus t plus c. So which is same as log of 1 plus t by 2 plus t, and now putting back value of t, it is log of 1 plus e power x by 2 plus e power x. So this will be the answer to this particular problem. Now moving to the next problem, 1 by x square plus 1 into x square plus 4. This is also using partial fraction. So here for doing partial fraction, we will take x square equals to t. This is not a substitution, it is just for partial fraction we are doing like this. So it will become 1 by t plus 1 into t plus 4. So that means a by t plus 4 t plus 1 plus b by t plus 4. So if you take the LCM, it will become a into t plus 4 plus b into t plus 1 equal to 1. So t equals to minus 1, you'll get a equals to 1 by 3 and t equals to minus 4, b equals to minus 1 by 3. So the values of a and b are 1 by 3 and minus 1 by 3. See, we are taking x square as t only for the purpose of partial fraction. So that means now we'll be writing in terms of x square only. So x square plus 1, x square plus 9, x square plus 4 dx. So a by, that is 1 by 3 dx by x square plus 1. As I told in the beginning, this is for easier partial fraction we are doing that, taking x square as t, not for substitution in integration, only for doing partial fraction. That's why after finding the values we are writing in terms of x. So down this is 1 by 3, 1 by 1 is tan inverse of x. This is minus 1 by 3, 1 by a is 2, tan inverse x by 2. So it can be simplified, 1 by 3 tan inverse of x minus 1 by 6 tan inverse of x by 2 plus c. So this is the answer for this particular problem. Now we'll move to the next problem. 15th one, cos cube x e power log sin x. So that is cos cube x e power log sin x. E power log sin x is nothing but sin x. So cos cube x into sin x dx. So this can be done with the help of substitution. Put cos x is equals to t. So that means minus sin x dx equal to dt. So that is sin x dx equal to minus dt. So now I will become integral of t cube and sin x dx is minus dt. So that is minus t power 4 by 4 plus c. So that is minus cos to the power 4x by 4 plus c. So this will be the answer. Now moving to the next problem, 16th one, e power 3 log x x power 4 plus 1. It is also similar to the previous problem, 3 log x by x power 4 plus 1 we can write dx. So this is I. So that is equal to integral of e power log x is x cube x power 4 plus 1 dx. Now put x power 4 plus 1 as t. So that means 4x cube dx equal to dt, x cube dx equal to dt by 4. So now substituting that here, dt by 4 divided by t. So that means 1 by 4 log t. Log t is log t plus c. So that is 1 by 4 log x power 4 plus 1 plus c. So this will be the answer to this particular problem, 1 by 4 log x power 4 plus 1. Now moving to the next problem, f of ax plus b whole to the power n into f dash of ax plus b. So f dash of ax plus b into f of ax plus b to the power n dx. This is also using substitution. So take f of ax plus b as t. So the derivative will be f dash of ax plus b into a dx equal to dt. So therefore f dash of ax plus b dx equal to dt by a. So if you do the substitutions here, f dash of ax plus b dx, it is dt by a into t to the power n. So that is 1 by a t power n dt. So this is equal to 1 by a t power n plus 1 by n plus 1 plus c. So that is equal to 1 by a f of ax plus b to the power f of ax plus b to the power n plus 1 by divided by n plus 1 plus c. So this will be the answer for this particular problem. Now we will move to the next problem. 1 by square root of sine cube x into sine x plus alpha. So let us take this as I, that is integral of 1 by square root of sine cube x into sine x plus alpha dx. So 1 by sine cube x. Now we will be writing sine x plus alpha using the formula of sine a plus b. So that is sine x cos alpha plus cos x sine alpha dx. Now we will be taking sine common from the formula which we have written now. So sine cube x is there, then sine x is taken outside. So sine x is one common here, so it is cos alpha, but there is no sine x here, so that means it will become cos x by sine x, that is cot x sine alpha. So first term is cos alpha, then cot x sine alpha. So now this is sine to the power 4x, so if it is taken outside the, it will come outside the root as sine square x. So inside the root now only these two terms are there, that is cos alpha plus cot x sine alpha, and 1 by sine square x is cosecant square x dx. So this is cos alpha plus cot x sine alpha. Now we will be doing the substitution, cos alpha plus cot x sine alpha equal to t. When we differentiate this, minus cosecant square x into sine alpha dx equal to dt, or that is, it is only cosecant square x dx. So cosecant square x dx equal to minus 1 by sine alpha dt. So now we will be substituting in this. So what we will be getting it as minus 1 by sine alpha dt divided by root t. So minus 1 by sine alpha is taken outside, so dt by root t. So 1 by root t integral is 2 root t. So that is minus 1 by sine alpha into 2 root t plus c. Now we will be putting the value of t, that will be the final answer, that is square root of cos alpha plus cot x sine alpha plus c. So this will be the answer to this particular problem. Now we will move to the next problem. Sine inverse of root x minus cos inverse of root x divided by sine inverse of root x plus cos inverse of root x. So here we are using this particular result. We have sine inverse x plus cos inverse of x equal to pi by 2. So that implies sine inverse root x plus cos inverse root x equal to pi by 2. So if we take the given integral as I, so that is integral of sine inverse root x minus cos inverse root x divided by sine inverse root x plus cos inverse root x dx. So that means The denominator is pi by 2. Sine inverse root x minus cos inverse root x dx. So 1 by pi by 2, that can be written as 2 by pi. So sine inverse root x minus cos inverse root x dx. Again, using the same sine inverse root x, we can write it as sine inverse root x. Can write it as pi by 2 minus cos inverse root x. So that means it will become 2 by pi by 2 minus cos inverse root x, that is for sine inverse of x, then minus cos inverse of root x dx. So this will become 2 by pi, then integral of pi by 2 minus 2 cos inverse root x dx. So now if you separate it, it will become 2 by pi into pi by 2, that is 1 dx, minus 2 by pi into 2, it is 4 by pi into cos inverse root x dx. So this is our I, so let us take this as I1 and cos inverse root x as I2. So this we will take it as equation 1. I1 can be integrated directly. Now we will be doing I2. So I2 is integral of cos inverse root x dx. So we are doing a substitution here. Put root x equal to t. Root x equal to t. So that means 1 by 2 root x dx equal to dt. So that is dx will be 2 root x dt. So now we will change that. So cos inverse of t, and dx is 2 root x dt, but root x is t, so it is 2t dt. So this is 2 into integral of t cos inverse of t dt. So this can be done using integration by parts by taking cos inverse of t as the first function. So cos inverse of t first function into integral of second, that is integral of t, so that is t square by 2, minus integral of derivative of cos inverse of t is minus 1 by root of 1 minus t square into integral of second, that is t square by 2 plus the constant. So now if you simplify this, it will become t square cos inverse of t, then plus integral t square by under root of 1 minus t square dt. So that is t square cos inverse of t, then this can be written as minus of 1 minus t square minus 1, it is adding and subtracting 1 minus t square dt. So that is, it will become t square cos inverse of t minus integral of root of 1 minus t square dt plus 1 by root of 1 minus t square dt. So that is, it will become t square cos inverse of t. This is using the formula of integral of root of a square minus x square dx, that is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c. So using that, it will become t by 2 root of 1 minus t square plus a square. A is 1 by 2 sine inverse t. Then this integral will be sine inverse of t plus c. So this much is the integral of cos inverse of root x, that is I2. So now let us write in terms of, or simplify this. So it is t square, t is root x equal to t. So that means t square will be x cos inverse root x minus root x by 2 and root of 1 minus x, then minus 1 by 2 sine inverse root x plus sine inverse root x plus c. So this third and fourth term, it can be combined. So it will become x cos inverse root x minus, this also you can write it as root of x into 1 minus x by 2. This will become plus sine inverse root x by 2 plus c, simplifying third and fourth term. Now we will be substituting in I for the final answer. So I will be integral of 1 dx is there, x, then minus 4 by pi 4 by pi 4 by pi into integral of cos inverse root x, that is I2, x cos inverse root x minus root of x into 1 minus x by 2 plus sine inverse root x by 2 plus c. So that means simplifying x minus 4 by pi x cos inverse root x plus 2 by pi square root of x into 1 minus x, then minus 2 by pi sine inverse of root x plus c. So this will be the answer to this particular problem. Now we will move to the 20th problem. Square root of 1 minus root x by 1 plus root x. So let us take this as I, square integral of square root of 1 minus root x by 1 plus root x dx. So we are going to do the substitution. Put root x as cos 2 theta, root x as cos 2 theta, or theta equals to cos inverse of root x 1 by 2 cos inverse of root x. So root x is cos 2 theta, so that means 1 by 2 root x dx equal to minus 2 sine 2 theta d theta. So that is dx is equals to minus 4 sine 2 theta into root x. Root x is root x d theta. So that is minus 4 sine 2 theta. Root x is cos 2 theta d theta. So now you will be doing the substitution here. Integral of square root of 1 minus cos 2 theta 1 plus cos 2 theta, and dx is minus 4 sine 2 theta cos 2 theta d theta. So minus 4 can be taken out, and integral of 1 minus cos 2 theta is 2 sine square theta divided by 2 cos square theta, then sine 2 theta is 2 sine theta cos theta into cos 2 theta d theta. So that is minus 4. This will simplify to tan theta into 2 sin theta cos theta. Cos 2 theta can be taken as 2 cos square theta minus 1 d theta. So one more 2 can be taken outside, minus 8 tan theta can be written as sin theta by cos theta into sin theta cos theta into 2 cos square theta minus 1 d theta. So this cancelling minus cos theta and simplifying, we will be getting it as sin square theta into 2 cos square theta minus 1 d theta. So that is minus 8 2 sin square theta cos square theta, then plus d theta plus 8 into integral of sin square theta d theta. So now sin 2 theta is 2 sin theta cos theta. So minus 8. This can be written as sin square 2 theta divided by 2, because sin 2 theta is 2 sin theta cos theta. So squaring that, sin square 2 theta will be 4 sin square theta cos square theta, but there is 2 sin square theta, so 2 sin square 2 theta, there is uh, 2 sin square theta cos square theta, so that will become sin square 2 theta by 2, then plus 8 into this can be integrated as 1 minus cos 2 theta by 2 d theta. So now minus 4, again sin square 2 theta, it is 1 minus cos 4 theta by 2 d theta. So this is plus 4 integral of 1 minus cos 2 theta d theta. Now that is minus 2 integral of 1 minus cos 4 theta d theta plus 4 integral of 1 minus cos 2 theta d theta. Now you will be integrating term by term. So it will become minus 2 integral of 1 is theta plus 2 into integral of cos 4 theta is sin 4 theta divided by 4, then to the second term 4 theta minus 4 into integral of cos 2 theta, it is sin 2 theta divided by 2 plus c. So 4 theta minus 2 theta, that is 2 theta plus sin 4 theta by 2, then minus 2 sin 2 theta plus c. So now we want to write in terms of x. So what was our substitution? Root x equal to cos 2 theta. So root x equal to cos 2 theta. So that means sin 2 theta is square root of 1 minus cos square 2 theta. So that is square root of 1 minus x. So theta is 2 into 1 by 2 cos inverse of root x, and sin 4 theta, it is 2 sine 2 theta into cos 2 theta, and 2 root of 1 minus x into root x. So that means it will become plus 1 by 2 into 2 root of x into 1 minus x, then minus 2 root of 1 minus x plus c. So that is cos inverse of root x plus root of x into 1 minus x minus 2 root of 1 minus x plus c. So this will be the final answer.